Lumi, your AI companion for planning, execution, and reflection, and user experience design projects. In modern life, time is no longer just something we experience. It is something we measure, schedule, and constantly manage. Productivity tools promise to help us save time, but many of them just turn daily life into grades and deadlines. In theory, task management should follow a simple cycle: plan, execute, and reflect. But in reality, this cycle often breaks down. People underestimate time, lose energy during execution, and avoid reflection when unfinished tasks make them feel frustrated. Let's meet Vivian, a final semester Master of IT student who struggles to balance study, daily life, and personal well-being. Her days are always packed. Every day she needs to go to campus and attend classes. She works hard on assignments and joins group discussions. In her daily life, she also needs to buy groceries, do housework, cook, and find time to rest and go to the gym. But everything overlaps. Different courses bring different deadlines, and her schedule often becomes full and messy. Sometimes she forgets one small thing, and it makes her frustrated. Sometimes she's simply too tired to keep going. She starts to think about using AI. Vivian begins to wonder, could there be an assistant that feels thoughtful and gentle, helping her manage life with less pressure? To understand whether her struggle reflects a broader challenge, we conducted fieldwork with students and young adults, focusing on how they plan, execute, and reflect in everyday life. We collected data through 15 semi-structured interviews and 6 online observations. Then we used open coding to extract key quotes, problems, and expectations. After that, we used affinity diagramming to group similar codes into clusters and identify 8 key findings. Based on this, we narrowed the design direction into 2 core challenges. First, users struggle to maintain a continuous planning, execution, reflection cycle. Second, users need AI support, but they do not want it to feel rigid or controlling. Therefore, our How Might We questions focuses on 2 goals: supporting the full cycle in a lightweight way and designing AI as a gentle companion that helps users without adding pressure. Based on this, we started prototyping from sketches and wireframes. At the low-fidelity stage, we explored different app interfaces, interaction flows, and Lumi's future form as an AI companion. Then we developed mid-fidelity wireframes to organize the main user journey and test the structure more clearly. Finally, we moved into high-fidelity prototyping and focused on 4 key functions: the AI pet system, the AI chatbot, reflection, and archive. Together, these features help Lumi support planning, execution, and reflection in a lightweight and companion-like way. To better show how Lumi appears, interacts with users, and connects with future devices, we created a 3D prototype. We first built the main models in Maya, including the watch, phone, icons, and text. Then we added textures in Substance Painter. Finally, we imported everything into Unity to set up the scene, animations, and retroactive effects. For evaluation, we tested Lumi's high-fidelity prototype through maze usability testing, post-test questionnaires, and semi-structured interviews. The results were generally positive, and users understood Lumi as a supportive AI companion rather than a controlling productivity tool. However, maze data showed that some key flows still had high misclick rates. Based on this feedback, we first improved the original prototype by adding features and refining layouts. Then the prototype was redesigned more holistically to optimize the visual experience, reduce visual noise, and make Lumi more companion-like and calmer. For the AI deployment of Lumi, Cloud was used to assist with coding, and everything is connected to a personal OpenAI account for embeddings and GPT-4 response generation. The backend runs a multi-agent architecture. An orchestrator coordinates 4 sub-agents, each handling a specific part of the pipeline. For the knowledge base, a Pipecone vector index was set up, and 3 categories of books were manually uploaded: planning and reflection, psychology, and spiritual wisdom, to support different conversation modes based on user preference. This is a fully functional AI. Every response user sees is alive, generated by LLM in real time. Next is the app demonstration. When users first enter Lumi, they complete a short onboarding process. They can customize Lumi's color and personality and set their preferred reflection rhythm. After onboarding, users arrive at the plan page, which is an AI chatbot. Users can start a daily, weekly, or monthly plan through shortcut buttons. Lumi understands the user input, generates a structured task table, and automatically saves it into Time Archive. The Time page works as a personal archive. Users can review daily, weekly, and monthly progress, check their calendar overview, record mood, write reflections, and add short memos to individual tasks. Users can also chat with Lumi at any time. The chatbot supports reflection and emotional check-ins. Users can switch between different AI modes such as psychology mode and spiritual mode. The AI also shows its thinking process and reference sources to improve transparency. For execution, users can enter focus mode. Lumi supports concentration through background music, visual themes, and the flower growing mechanism. The longer user focus, the more flowers they collect, and they can send it to people they care. The Lumi page is the companion system. Users can unlock outfits, expressions, backgrounds, and badges. Lumi can also record small memories through Lumi Secrets, but this can be turned off in settings. Overall, Lumi supports planning, execution, and reflection in one continuous, low-pressure experience. For next step, we will continue to refine Lumi's AI interaction flow, test the redesigned prototype with more users, and explore how Lumi can support planning, execution, and reflection across different devices and everyday scenarios.